Proportions are when you have two equal fractions. So an example of proportion would be something that we know is equal. I'm going to give you an easy example here. For instance, I know that 3 over 6 is really the same as 1/2. 3 is half of 6. So this is an example of a proportion. It's two equal fractions. They're written differently. They look different, but they're the exact same thing. And in algebra, we often get a proportion with variables in it. Something like this, like x over 2 equals 3 over 4. And so one of the ways we can go about solving it is we can kind of just treat it like a typical equation. I'm going to put a line down the middle here. And we're going to solve for x. And, a lot of people talk about this concept of cross-multiplying, which you can do on a problem like this. If you were to cross-multiply, what that means is you're going to times the 2 this direction, and you're going to times the 4 this direction. And that would mean you'd have a 4 times an x on this side, and a 2 times a 3 on this side. And 4 times x is 4x, and 2 times 3 is 6. And you'd get to here, but remember we're trying to solve for x, so the next step would be to divide by 4 and divide by 4, and x is going to equal 6 divided by 4, some decimal, or you could reduce that down. 6 over 4 is really the same as 3/2. So you can say the answer is 3/2. 3 divided by 2 is technically 1.5 as a decimal, so you could say 1.5 is your answer. Any of these would work, 3/2 or 1.5. You could have made this problem a little bit simpler, and I'm going to rewrite it over here. X over 2 equals 3 over 4. By not really deciding to, I'm going to put a line down the middle, cross-multiply. Cross-multiply, people kind of get caught up in that term. They see two fractions and they just say, I got to cross-multiply. Well, you want to be a little careful. Like, you don't have to cross-multiply, because if I had decided to say, you know what, I'm going to multiply both sides by 2 to get rid of this 2 and times it over here, I would have had x all by itself by doing that, which is what I'm trying to do, is get x all by itself. And over here, I'm going to do 2 times 3 is 6, and I have over 4. And I'm already to this step that I had down here without cross-multiplying. And 6 divided by 4, we just established, is a decimal. It's 1.5. Same exact answer. A few less steps. I didn't have to do this thing right here. I didn't have to do 4 times x because I didn't cross-multiply. So you get to choose. You can cross-multiply if you want. It just adds an extra step. Or you can avoid it if you can. I'm going to avoid it when I can. I'm going to solve this next one over here. 2x over 3 equals 8 over 6, line down the middle. I'm going to try and solve for x, so my idea here is to get rid of the 3 by timesing 3 to both sides. If I multiply by 3 on both sides, these cancel, and I get left with 2x equals 8 times 3 is 24, so I have 24 sixes. And 24 6 over 6 means 24 divided by 6, and 24 divided by 6 is 4. So I get 2x's equals 4. And so my final step down here is I'm going to divide by 2 and divide by 2. And now I'm going to get x equals, cancel those out, 4 divided by 2 is 2. X is equal to 2. And there's my answer. So that's kind of the general pattern to solving a proportional problem. They do get more difficult. I mean, we can make these harder. For instance, we could make it something more like this. X plus 2 over 3 equals 4/7. Now you really want to be careful, because if you're going to go for the whole cross-multiplying strategy, think about what that's going to look like. If you're one of those people that really likes to cross-multiply and you're going to say, oh, I'm going to cross the 3 and the 7, basically. Well, that means you're going to have to take x plus 2 up here. I'm going to put a parenthesis around it and times it all by 7. You're going to want to be real careful about that. And then we'll times the 3 over here. So we're going to have 7 times quantity x plus 2 equals 3 times 4, which is 12. So I'm just going to write that. 3 times 4 is 12. And then I'm going to have to multiply the 7 in using the distributive property. So I'm going to have 7 times x is 7x, plus 7 times 2 is 14, and that equals 12. If I want to keep going here, I'm going to subtract the 14 over, make it a negative 14, and 12 minus 14 is negative 2. So I have 7x is equals negative 2. And in my last step, I'm going to divide by 7 and divide by 7 so I can cancel these out. And I'm going to get x is equal to negative 2 divided by 7. That is definitely going to be some sort of a decimal. So negative 2 divided by 7 is going to be my answer. I'm going to leave it as a fraction. And I'm done. You didn't have to cross multiply on this one. You could have done what we were doing in the other examples. You could have done this. I'm going to rewrite it up here. X plus 2 over 3 equals 4/7. Line down the middle. Why not just times both sides by 3 so that these cancel and get x plus 2 equals 3 times 4, that's 12/7. And then all you would have had to do is subtract the 2 over, and you would have had x is equal to 12/7 minus 2. So 12/7 minus 2. And 12/7 minus 2 is the same as negative 2/7. And I would have got the same answer. So you pick. There's no one way you have to do these problems. You can do the cross multiply thing, or you can do it like this second option over here. Whatever strategy you're more comfortable with. Either way, you're going to get down to the same answer. And that is kind of how proportional equations look.